Hi everyone. This section will cover the base security practices and Docker capabilities from which the containers can be provided with more features. While Docker provides central registry to store public images, you might not want your images to be accessible from the world. So in this section, I will teach you how to use a private registry, and I will review the Docker Content Trust and Docker Registry, which will provide you with a secure way to upload your images in Docker Hub. So from the security point of view, Docker containers use the resources of the host machine, but at the same time they have their own runtime environment. This means a Linux container cannot access other containers or underlying operating systems. And so the only way to communicate with other networks and containers would be with a specific network configuration. The most significant advantage of container-based virtualization is that applications with different requirements can run isolated from each other without having to assume the overhead of the separate guest systems. So, as you can see here, the container technology takes advantage of two basic functions from the Linux kernel. Those are the namespaces and the control groups. So on one side, the namespaces will provide isolation for the processes and mount points, so the processes that run in a container cannot impact with each other or see processes that run into other container. So the isolation of the mounting points implies that they cannot interact with the mounting points of other containers. And on the other side, the control groups or the C groups are a feature of Linux kernel that supports the limitation of use of resources at the level of CPU and memory that a container can use. This ensures that every container will get only the resources that it needs. So the development team behind Docker is also aware of security problems, considering them an obsolete for the consolidation of the technology in the production system. So one of the key isolation techniques that Docker Engine supports are firstly the AppArmor, which allows you to regulate the permissions and the access of containers and file systems. Then you have the SE Linux, which provides a system of rules that allows you to implement access controls to the kernel resources. And finally, you have the secure computing mode or the SecComp, which monitors the kernel system calls. So while Docker facilitates virtualization work, sometimes we might forget the security implications of the execution of Docker containers. We must always keep in mind that Docker requires root privileges for working in normal conditions, and you should always keep that from a security point of view. So the Docker daemon is responsible for creating and managing containers, which includes creating file systems, assigning IP addresses, routing packets, process management, and tasks that require administrator privileges. So for that reason, it is quite important, as I mentioned, to start all the daemons as administrator. So starting new containers, stopping, reconfiguring, or running them, some of the main actions we can perform on the containers. So one of the Docker ultimate goals is to be able to run even the daemon as a non-root user without affecting the functionality or delegating operations that require root privileges. So let's see some of the best practices when talking about Docker security. So you can see that one of the first and the most important practices are the fact that you should always run the Docker processes on a dedicated server isolated from other virtual machines. It is always very important to take special care to link certain Docker host directories as volumes because a container can gain full read and write access and perform critical operations to those directories. So, from the point of view of security communications, the best option is to use SSL based authentication. And you can definitely check on the web what the SSL protocol is. It is pretty much the most popular security control out there. Also, you should always avoid running processes with root privileges inside the containers. We will also talk in the next videos for how you can enable, and this is one of the key principles, how you can enable specific security profiles. And those are the AppArmor, the SE Linux on the Docker host. So you should always keep in mind that all of your containers are actually sharing the Docker kernel. So it is quite important to have the kernel updated with the latest security patches. So since this course is covering the complete DevSecOps features, let's talk about some key principles for improving the container security. So you should always use only one application per container that is using microservice-oriented approach. You should never run containers as root, and you should also make sure to disable the set UID permissions so nobody can interfere with that. You can also use, and I will actually talk about this in the next videos, so you can use the cap drop and the cap add flags to remove and add capabilities of your container. It is also advisable not to use environmental variables or run containers in privileged mode if you are going to share secrets. You should also have Docker updated to the latest version to ensure that all security issues have been solved, and at the same time you have the latest features that Docker is incorporating in its core. And also, you should always bear in mind that kernel is one of the most vulnerable components of the container management because it is shared between all containers. So you should always take a special care to keep the Linux kernel with the latest update as well. So let's go guys to your terminal, and hopefully you should already have Docker installed and Docker opened right here. You don't need all of those containers that I currently have installed because we will update with new containers as well. You don't need that in order to execute the commands in the video. So let's go to our terminal, and the first thing I want to cover is that all the containers are actually defaulted as having root by a default user. Okay, so every time you create a container, you will immediately be assigned to the root. So for example, if I want to create a new Ubuntu machine without any user specifications in the creation, here's what I will get. So you can type docker run -v bin host bin, then let's do it --rm ubuntu sh. Okay, so when I run that, we just created an Ubuntu machine, and you can see it right here in the bottom. It is currently running because we selected the run command. So now we're here in that machine, and you can see we're right now in the host shell. So let's type who am I. Okay, and you can see that by default you're already the root user. And if you do ID, you will get that all the IDs that you currently have are the root user ID. So you can see that containers are executed by default with the root user. So root privileges will be available within the container. However, from the security point of view, it is important to configure the namespaces to limit access to the container as user. So while container engine must be run with the root privileges, it is not a good practice for the containers to do the same thing. So the container engine in that case is the Docker. However, the containers are just entities into the container engine. So for that reason, it is quite necessary to create a user for each running container. So the best way to do that is to indicate the user who wants to be able to execute the creation of the image in the Docker file. You can add users inside the Docker file, and I will show you how this is done. It is quite simple. So I'm going to create a new folder on our desktop since it is the most convenient for me. And this folder right here, I'll name it 3_root user. Okay, so the name actually doesn't matter, but what's inside actually matters. So in that folder, I'll create a new file with the Sublime text. So let's do Sublime text and let's create a new file. I'll save it and let's name it Docker file. And this file will be used for us to create a new image which will have different sort of privileges. So let's see how this is done. I'll write here from Python latest. So this means that we will create a new image from the Python image. Let's do run user add -s and then let's do bin bash unix user. Okay, and then let's do user unix underscore user, and finally I will do entry point. Okay, and here I will write bin / bash. Okay, so let's save that file, and now let's go in the terminal, and from there I will go into this folder. So let's exit our container. Okay, and just close the container. So I will do cd and then I will go to our folder. You can see that our Docker file is right here. So you can build the new image with the following command: docker image build -t, and then the name would be Python image. Okay, so this will create a new image from our Python image, and it will use a Docker file to customize this image. So let's run this. And yes, you need to place dot in the end. I always forget about this in order to get all the files. So let's run that. And you can see that now a new image is created. And if now I write docker images, you can see that here we're having a Python image that is currently created. Okay, so if you want to run this particular image, you can write docker run -ti and then let's write Python image. Okay, so let's run that. And if I go back here, you can see that we're having our Python image and it is currently running. So this is the exact same image that we just created. And you can even see from the name that we are already a Unix user. So if you write who am I, okay, you see that you're a Unix user, but you're not root anymore. So only with this simple thing, when creating images, you can make sure that the user that is using your image is not a root user. And if I add ID here, you can see that absolutely everything, the user ID, the Git and the groups, you're all there as Unix user. And so you can see that now the user is added inside the container by inspecting actually the file etc/password. And you can actually check the content of this file but by simply writing more etc password. And if I search here for the users, you will find out that first of all this is our root, and also if you go down here at some point you will find your Unix user. So you can see that he is right here in the bottom since we last created it, and this is where it is, right? It's a bin bash user. Okay, so this is how, guys, you can pretty much automatically create your root user without any issues. So another quite a good practice that is recommended for Linux systems to have minimum privileges. So flags such as read only can be applied to the existing container. So limiting the use of the file system can really prevent potential attacker writing and executing scripts inside your container. So we can use, in that case, the docker run command with a read-only flag for this. So how do we do that? Let's first exit our container, okay, and you can see that there is nothing running into our Docker application. So you can do docker run it -read only, okay, Python sh. Okay, so let's run that, and you can see that here in Docker we actually run a Python version. So for example, if you want to touch some of the files, you will see that we have only read-only permissions. So if I write, as you can see, touch file, we're getting an error, so we cannot touch a file because we have read-only file system. So this is quite a good practice, but it also has disadvantages. And the main disadvantage of using read-only option is that the most applications need to write files and dependencies, such as the ones in the /tmp folder. And this will not work in read-only environment. In those cases, you can use folders and files in which the application needs write access to use volumes to mount only those files. So that type of volume can be provided to make persistent changes into the container if the container needs that and needs to write a file into the file system. So it is recommended if you're using Docker to use Docker volumes only in case of temporary files. So a volume, as you can see here, is actually a directory that is separate from the root file system of the container. It is managed directly by the Docker daemon process and can be shared between containers. So for example, you can create a MySQL container, configure it as read-only, with exception of some of the folders in which you would want to write files, and we'll try that. So for example, if I want to create a MySQL container, since this container needs a lot of dependencies, it will be hard to create it without volumes in a way that it will have read-only permissions. So let's see what would happen if we try to do that. So let's do docker run name MySQL read only, okay, and then do MySQL. So this should create a container called MySQL from the MySQL image, right? And this container should have read-only permissions. Let's try to do that. And you can see that we have some logs here in front of us. So we started the container and so far so good. However, at some point when we tried to create the Docker entry point sh, we had to write this file. So since we're a read-only file system, we cannot write this file. And for that reason, if I go here to MySQL, and I try to run the container constantly, you can see that it doesn't work. It never wants to run. And this is because this container is dependent on overwriting files. And you can even see that from the log. So if I go to view more details right here, you see that we're read-only file system. So for that reason, we couldn't add the dependencies. So how do we fix that? Well, so firstly, I can see that here we need access to this folder. So what I will do is, before specifying which image I want to use, I will do -v, which will create a volume, and I will create this folder here. So we'll do user local bin. Okay, so I'll copy that and paste it right here. And I will also create other volumes. So let's create a volume to the MySQL library where we'll have another dependencies. So I will do here var lib MySQL. Let's do another volume of the TMP folder and another volume on the var run MySQL ID. So let's try to run this command as it is, and you will see we'll get one specific error that I want to talk about. So let's run that. First, of course, make sure that you remove the previous MySQL container so you can create another one with the same name. So let's run that. And you can see that here we got another error which says database uninitialized and password option is not specified. So always when you add volumes, you will need to specify password. And to do that, you can see that you have a few options here, and I will use one of those actually. So I will do -d, -e, and here we will create a password. So let's create MySQL root password. Okay, and this password, let's be equal to password. Okay, because we don't care. But if you create it for your file system, you would want to choose something more complicated, of course. So let's run that. Yeah, so and we need to first remove the previous container. Okay, so let's try to run it again. So before running it, I will actually remove one of our volumes. I will remove the user local bin because this is covered by one of the other volumes that I currently created. So this shouldn't give any problems. So this will be the final command that I will use. One typo that I noticed is that here I wrote MySQL ID, but in fact the right folder is MySQLD. Okay, so fix that, and then you can run the command as it is. So again, what we're creating here is simply creating the container with read-only permissions, but we're creating certain volumes in which you can read and write in order for us to be able to instantiate all the dependencies for MySQL and read and write in those volumes. And then we got required to create a password when we were creating a read-only container. So let's run that, okay? And you can see that there is a process that has been created. So let's go back and check if we have something running into our Docker Hub. So if I go here, you will see that now MySQL is running. So we successfully created it. And if I go to the logs, you will see that we have no errors here. So this is how you can start a container and mount a volume in a read-only mode. And so the final security feature that I want to share with you is how to disable the set UID and set git or GID, because if you can set those, then this user would have permissions that will access the directories and the files of the operating systems. Okay, so if you don't disable those, even users without root permissions can actually edit those files, which means that they can edit your operating system, which is something that from security point of view is definitely not optimal. So the best practice would be, in the first place, to disable the set UID permissions and to actually disable them from the Docker file. So there are two ways in which you can disable those, and one way is from the Docker file. So for example, if I open our Docker file from our previous project, okay, here where the run statement is, you can simply write run find /dash perm plus 6000 -type f-exec chmod a-s curly brackets semicolon and then two pipes. This command performs a search for executables and withdraws any set UID or set GID permissions from the user. So if that sounds a little bit complex for you, of course you can use that command while creating the image, but you can also disable the set UID and set GID from the creation of the container. So maybe you have an image that don't have those disabled, but if you want your particular container to have those disabled, you can do docker run -d cap drop, okay, and then let's do set GID and then cap drop set UID and then the container name that you want to run. So let's do Python, for example. So what this will do is simply create a Python container and it will drop. So we have here cap drop, and we will talk about cap drops in more detail in the next videos, but this will simply drop some of the functionalities. So it will drop the set GID and it will drop setting the UID. So if I now hit enter, this would create a new container, which will be a Python container that will have those options. So that's it. Thank you very much for watching this video, guys. And in the next one, we will talk about the Docker Content Trust. Thanks for watching.